Good morning, students. Yesterday we had completed the explanation of scatter diagram. What is scatter diagram and how is it visible? How can we make the scatter diagram? So we'll see how scatter diagram is. Scatter diagram looks like this: a scattered value of analyzed functions depending on x-axis and y-axis on the paired data is being plotted over the graph, and this is how your scatter diagram looks like. So scatter diagram is a relationship between your paired data, that is the relatable data which is being calculated for analysis. So on grid line or graph paper, how to calculate the scatter data? So this is how they calculate the scatter data. So step 1 is draw an L just form, just like on the Pareto diagram. So you have to draw just an normal L like diagram to on the plot, that is a Pareto graph. Make scale units of at even multiples such as 10, 20, 30, so on. So even consistency like 15, 30, 15, 30, 45, likewise increments you have to make of the same consistency. And on the horizontal axis you place the independent or cause variable. So on the x-axis here, x-axis you can place the independent values, that is the cause, and on the y-axis you have to place the variables of effect, and plot your data points of intersection. So depending on the number of values which you have, on that basis you have to plot the values and check to go right 5 spaces and then go up to 2 spaces to plot the point. So x is equal to 5, so 5 points here, and then 2 spaces for y on the x plot for the effect you have to calculate, according to which your intersection of that particular scatter point you will get. So suppose it's 5 here and 2 here, so here will be one scatter plot. Then here, if the next 5 is here and your scatter plot is 2 somewhere here, that is 4 multiple of 2, then here one scatter will be there. Likewise you have to calculate the scatter diagram plotted. The next one is a run chart. A run chart is a graph of data in chronological order. Chronological order means in ascending order, that displays changes and trends in the central tendency, that is in the average value they will set the central tendency of the data. The data represents measures, counts or percentage of outputs, that is products or services from a process. So from a process what they will count is they will measure, count the data and calculate a percentage of those outputs depending on products or services what are there in the process. Run charts are often used to monitor and quantify processes. So as they have measures and percentage, means obviously they will be quantifying, not quality, it's quantifying, that is the quantity will be taken into consideration outputs before a control chart is developed. Before a run chart is developed, they will quantify the values. Run charts can be used as input for establishing control charts. So run charts can also be established for the use of control charts. Run charts track events. So what are the track events of run charts? Total failures, the track events such as total failures, complaint levels, end user satisfaction level, suggestion levels, training efforts, production yields, number of invoices, number of system errors, downtime, that is downtime means how much time the server was down, it was not used, that is in minutes and percentage. So the total failures, how much are there, how many are calculated, complaint levels, what problems encountered through those failures, end user satisfaction level, after the delivery the product is end user satisfied or not, suggestion levels, what upgrading should be made using the suggestions, training efforts, training the employees for a particular cause, production yields, how production is going on over the particular product, number of invoices, how documentation is done for those data, number of system errors, what are the major system errors which are being found out, and downtime means how much time the server was down, people were not able to access it, that is the downtime. So next is the steps for developing a run chart. So when we try to develop a run chart, what are the steps that can be taken for developing a run chart? Decide which output of a process to measure. So which output should be quantified to measure the run chart. Label the chart both vertically and horizontally. So labeling it from both the axes, that is vertically for quantity and horizontally for time. Then plot the individual measurements over time. So each and every individual measurement should be given over time. Tracking the data chronologically in time. So tracking the data in ascending order on the basis of time should be calculated. Connect the data points for easy use and interpretation. So which are interrelated, you can connect it through x and y axis, that is horizontally and vertically. Then monitor the data points for any obvious trend. Monitor the data means if any changes are, monitor the data properly. A run chart may be used to study, observe data for trends or patterns over a specified period of time. Focus attention on vital changes in the process. So if there are any major changes or important changes in the process, that time, over a period of time, there should be change in the trends and patterns of that particular chart, that is a run chart. Then a run chart is useful for tracking information. For tracking the information and predicting the future trends and patterns, run chart is very useful. Then it can determine if a process has common cause or special cause of variation. So yes, if there are changes, variation means changes. So changes, if there are there, what changes are ideally dependent, that are those changes dependent on a normal cause or it's something a special cause for that change. Then these are the important, this is important because process fall into one of the 4 states. So there are 4 states in which your process falls, and that is the reason you need to find out the variation and randomness of the patterns of a run chart. And the 4 states are idle, threshold, brink of chaos and state of chaos. So what are idle is normal at that state, that is idle state means doing nothing, just performance over time, stability is being given to the machine or process. Threshold is a process that is in threshold state is predictable, however it does not consistently meet customer needs. Threshold means it will be working backend but it is not completing the customer needs, it is going on according to its task or its duration. Brink of chaos state reflects a process that is unpredictable. You cannot predict the value of brink of chaos, but the outputs of the process still meet the customer requirements. Even if brink of chaos state is unpredictable, but still it will complete the customer requirements which are there. The fourth process state is state of chaos, which process produces unpredictable levels of non-conformance. It will give you any output, it is not customer convenient, and that is the reason you cannot actually gather the data what customer actually requires. So there are 7 steps of creating a run chart, that is decide on the measure to be analyzed, gather the data, at least minimum 10 data points should be there to calculate a run chart. Draw a graph with vertical and horizontal line. So with the vertical and horizontal axis, that is x and y axis, you have to draw the chart. On the vertical line or the y axis, draw the scale relative to measuring, that is the measuring values, and the time duration of those completion values should be given on the x axis, that is the horizontal line. Calculate the mean and median. As it is quantifying and calculating the average and percentage, you require mean and median, as well as draw a horizontal line at the value going across the graph. So you have to draw again across the graph. If it is exceeding the value, then you have to again draw one horizontal line for that points. Next is first look of runs, that is a run is a sequence of consecutive points which all lie on the same side of the mean median. So if all the consecutive points which have the same consistency or the trend, they will be calculated as a run or a run sequence. Ignore the points that are exactly on the line. So on the line, if any of the point is there, then that will not be calculated. Simple count of numbers of runs. So number of runs may be calculated usually. So the chart after analysis has 3 columns, that is number of data points, lower limit of runs and upper limit of runs for each case of value which they put on the mean or median. So after that, the next topic which comes is quality cost. So quality cost is part 3 of this unit, that is chapter 3 unit 3 part 3, that is the end part of this chapter and the syllabus as well. So it has major 3 to 4 topics I recollect, that is defining quality cost, then you have after that types of quality cost, then you have quality cost measurements, and the last topic is utilizing quality cost for decision making. So these are the 4 topics which we will cover in part 3, and then we'll end up with this syllabus of software quality testing, software testing and quality assurance. So quality cost, again, what is quality? Every project activity has cost and it must yield excellent business value. For software testing is no exception. So obviously when you are paying something, you should get a proper quality, is the actual quality cost. Test managers should test in a way that its business value is maximized. So business giving a best quality enhancement will increase the business analysis or business value in the market. So test managers should check that also. Too much of testing would cause unnecessary delays. A lot of testing unnecessary will give a delay to the customer and end up incurring more cost. As in how you keep that product, you keep on processing it, you keep on testing it, it will require cost as well as time. So rather than delay and time, you can go for proper deadlines of completion. So what is actually cost? Defining quality cost. Cost of quality is one of the most established, effective of quantifying and calculating business value for testing. So for business value of testing, we do quality cost, which is dependent on effective measures of quantifying and calculating the business. So calculating the business value, we have quality of cost of quality. So there are 4 categories in which your quality cost is being defined: prevention cost, detection cost, internal failure cost and external failure cost. So prevention cost is this cost is training the developers. Detection cost is any creating test cases, setting up testing environments, revisiting testing requirements. All these things are in detection cost. Next is internal failure cost, if any error occurs. So in the cost required for fixing those defects can be internal failure cost. The last is external failure cost, includes the incurred by delivering poor quality software. If you have delivered a abnormal software, then the external failure cost is also paid by the business organization. So that is termed under external failure cost. With this, we'll stop here for this chapter. We'll continue next topics in tomorrow's lecture, and probably by tomorrow we'll end up with this chapter. Thank you. Please fill the attendance.